how do we reduce the risk from UXOs? First to Anders, because I've got avoidance. How can we avoid them? And is it expensive to do so?
Yeah, well, the to avoid the UXO are probably the most simple way of mitigating the risk. If you have a cable route, you can simply reroute the cables to through the exclusion zones of the UXO that have been found in the area. You will obviously have to account for if you have a cable, it can bend quite a lot, so you can zigzag in and out. If you have a pipeline, you have to be more straight, it's stiff. If you have a structure, it might not be able to move it to places somewhere else. And if you decide to redesign, it can be quite expensive. Normally, UXO surveys are also could be quite expensive to perform. So you usually perform these surveys in narrow corridors or around borehole positions in small boxes and so on. So if you decide you want to avoid a target, you might have to conduct a brand new survey, expanding the area, and then it might actually be more viable to simply inspect and remove the or designate the UXO object.
Yeah. And if you're working in, let's say, sand wave areas, which are mobile, and we've seen wrecks move around in sand wave areas and can sort of migrate, up to 100 meters or more. I've come across in high tidal areas. Is that the same with the UXOs? Can they migrate in sand wave areas?
I believe the usual maybe all can also have some knowledge about that, but usually we say that the UXO will not migrate due to sand wave activity, but obviously the burial depth of the UXO will be greatly affected by moving sand waves. 1 year they can be exposed on the seabed, and a few years later they can be below a 6, 7, 8, 9 meter tall sand wave and be effectively out of range of detection of the UXO systems.
So that poses a different problem, doesn't it, when you've got a mobile seabed?
Yeah.
Yeah. Okay. That's good. So the next stage is, if we can't avoid them, there's a possibility of removing them over to oak. In Germany, for example, quite often the UXOs are transported ashore to be dealt with. It's something which I've not really aware of being so common in UK, unless it's something rare and somebody wants to investigate the weapon a bit further. Is that your finding, Jan?
So yeah, lift and shift operations of UXO in Germany are more or less forced by the government, and that's the only reason for that is to avoid noise peak detonations subsea. But to relocate a UXO, you need to be 100% sure what type of UXO it is and what kind of fuse it's on the UXO. Without a 100% ID of knowing the origin of the target, the type of fuse, the state of the fuse, you cannot move safely UXO back to deck or do a lift and shift to the beach, for example. But yeah, in Germany is more common than in the UK. In the UK, you will see lift and shifts to avoid detonation near subsea infrastructure, for example. But
I was going to say, Hannah, you might have a bit more of an insight as to UK going to go more for air detonations, which cause far less environmental damage than underwater explosions.
It's not something that I'm aware of, but I know that the UK government at the moment are piloting a lot of studies that are looking at how we can reduce the noise created in a lot of sort of offshore industries, wind farm installation, and I'm this is almost certainly this as well, because they all have the to a different amount for each, but same resultant risks. But yeah.
So there's no sort of strict policy that's been formulated yet.
Not for not that I know specifically to do with lifting them out to detonate them outside of the water. Not specifically that. Obviously, we have our methods in which we can try and reduce the noise emitted if in the event that detonation is required. We have various noise abatement systems, mainly the bubble curtain actually, which Germany use a lot for various offshore industries, and it's something that we've adopted here in the UK for high order UXO detonations.
Okay, well, yeah, that brings us nicely onto the destruction side, the high order and the low order, the detonation or deflagration, and there's been a high-profile campaign in UK from Joanna Lumley to adopt low-order deflagration, because the noise emitted from that is far, far smaller than a full explosion. And certainly that's been used up in Scotland, and it appeared to be quite successful. And I assume that from a marine mammal observer's point of view, is that easier for you to monitor?
Oh, absolutely. I mean, the precautionary principle that we follow in the offshore industry as a whole, but specifically in relation to the marine environment, is really important. And if you are towards the sort of last options of having to sort of detonate the bomb, the UXO, sorry, deflagration should always be considered, because the resultant effect on the damage it can cause to marine mammals is really significant compared to detonation. So yeah, I think absolutely consider the low order techniques, and if they absolutely don't work and the high order are required, then obviously we've, as I mentioned, we've got noise abatement systems, but the importance for sort of thorough planning is really, really important. A really thorough environmental impact assessment, using noise modelling, to try and estimate the sort of impact ranges of various sized UXOs, environmental considerations, so depth of water, and then obviously, depending on the potential effect, looking at what noise abatement systems you can use, having a strong marine mammal mitigation plan in place, which, you've got a good team of marine mammal observers, passive acoustic monitoring, and the use of acoustic deterrent devices. They're all options that we can employ to just try and bring the overall impact down to sort of the most negligible level as possible. Yeah.
What's your experience of deflagration versus detonation? Is deflagration the silver bullet, or are there still some issues?
There is no simple answer to that. High order detonations fully eliminate the risk, but generate noise, of course. We want to reduce that noise, but low order detonations by deflagration, for example, it's not as easy as answered as you say. Yes, it has less noise peak subsea, but you see most often that you need to do a secondary attack because you have leftover residues, or you have booster jars still in place. You need to reconfigure your secondary or third attack to determine if all explosives are gone, yes or no.
Yeah.
So by introducing low order techniques, you might end up with more vessel days per disposal. So in some cases, up to 3 days, you are in the field with not only the disposal vessel, but also with the noise mitigation vessels, with the bubble curtain vessels. So on one hand, you reduce and you safeguard the marine mammals, but on the other hand, you have pollutions, topside, of course. So it's not a simple answer to the question: is low order better than high order? Yes, in some cases it is, but there are new techniques coming, and I feel that the offshore industry is not ready or not willing to introduce those new innovations, and that's a little bit of a pity, because there is more than low order and high order detonations.
An interesting question just come through. What's the likelihood of an unintentional detonation when trying to neutralize UXO using low order methods? I know that that big tall boy did go off and it wasn't supposed to in Polish waters.
So you have that we call it like a violent low order. That's a low order that ends up in a high order. There is no 100% guarantee that a low order will be successful. So I always try to plan for a violent low order. So mitigate the low order as it's going to be a high order.
So you've got to use a bubble curtain there as a backup, just in case.
Depending on the size and the TNT calculation on the target, of course. If you have a small artillery shell or you have a British ground mine, that makes a huge difference in noise peak.